All right, we're back. Day 4 of streaming and day 4 of the DSPy project. Most important thing is we should start off with a nice organized to-do list. We have a GitHub now, so I set up a GitHub on my public account. So everything I do here is going to be open sourced, which is pretty nice. That reminds me, I should add a license file, but it's going to be something permissive. And I'm gonna paste the GitHub. So we have a GitHub. I'll paste it in the video description too if you watch this on YouTube. But it is here. So it's my GitHub account /streaming. What do we want to do today? Or let's start with the to-do list. Well, I think we want to do two big things today. So to-dos for today. We'll recap where we left off, but we modularized the adapter we did last time. So our custom adapter for generating include instructions, or let's say Python import statements, right? Specifically for Python. So the first big thing we'd like to do is we'd like to add code execution feedback. Because even though we tell a model, an AI model, to generate those import statements, we need a way to validate if they're correct. So could also be done with code parsing, but we don't want to do that. Because we would have to write, feels like a bit too many rules. Is there a way to strike through text in Notepad++? Strike through text, Notepad++. Okay, it's from the font settings. Style configurator. Oh boy, there's no there's no strike through here. What's happening? Change the default font to a strike through font. Default style. Yeah, this looks way worse than I'm not sure what's happening here. So there's no strike through, but we'll use the markdown syntax. So yeah, we're not gonna do it with parsing. No, we would rather take the code the AI outputs and exercise it. And what that means is we have to write a new DSPy module. So we need to write a new DSPy.module capable of ingesting feedback. Could use some existing modules, maybe. I think there is at least one called Refine, which sort of is capable of taking feedback and trying things again, right? So we want a module that has this capability and is general enough, because all DSPy modules are general. So the capability that we want to implement here is, in fact, it's even the critical point is the second one here. We just want a DSPy module, a module that can try things again. Or let's call it even more precise. Try again, or try another response from the LLM with some hints. And this works for any task, right? Because it doesn't matter if you're trying to make a model do math, if you're trying to make a model output code, if you're trying to make a model answer questions about history, science, whatever. So yeah, let's try to do this. Let's see what's happening here. Let me add the background too. All right, we should have some background music too now, which is pretty nice. Okay, so this is the first big thing. Yeah, we don't want to do parsing. Maybe DSPy refine, we'll see. Maybe not, most likely not, because it's more fun to write our own. But we definitely sorry about that. We definitely want it to be a DSPy module because we want to reuse this for any task. The second big thing we want to do is use this module to I don't think we'll have time today. Unlikely today. Use this. Let's make it more generic. Use the DSPy module to generate DSPy adapter code. Okay, because let's see here. Let's try to switch to what we saw. Okay, is this all visible? Not really. Okay, so well, we saw the reason why I kind of moved this out of view is that we remember from, and this is a good time to let's do the recap. So what we did last time, is we ended up with 2 files now. So the project's a bit more organized. There's a main code, which defines our main DSPy module, problem solving. Again, if you've been following the series, it's a 2 input 4 output module whose job is to solve lead code style problems. And we're not really evaluating this yet because we'll have to set up a data pipeline, but that's for a later date. It's not the biggest concern so far. The reason why I say that is because we kind of already know that LLMs are pretty good at solving competitive coding problems, so it shouldn't be a big of a surprise that none of these prompts really matter. But what we're interested in is sort of the infrastructure behind using AI like this. And for that, we added an extra input to last time we wrote a custom adapter, and it's all hooked through this extra input to our module, which is a good old regular input field, but it has a non-string description, right? The description is a Python variable, which is an entire file structure. And that file structure is built, we sort of kind of reinvented the wheel here, but there's like folders and files, and we wrote 2 classes for them, very basic bare bones classes where a file has a path and the folder also has a path and files and subfolders. The biggest thing is that the file has dependencies, right? So these are not just files, maybe it's better more accurately to call these code files, because in pretty much all or many programming languages, files are close, well, contents in one file are meant to be reused in other files, most likely, right? Unless you're writing a giant monolithic app, which is probably not a good idea. So that's why this file class has this depends on field, which is a list of, I wonder why is it not a list of other files? This seems like yeah, this seems like a mistake here. This should be a list of files, right? You want a file to depend on, at least for Python and for Rust or other programming languages, where sort of files are modules. So okay, so that changes how, because okay, yeah, so I have to, everywhere I see depends on, I just have to take its path now. Okay, so dot path. That's it, because the dependency map already extracts paths now. So it's more accurate to call this depends on path. So these are actually paths. Nah, it's too dirty to change that everywhere, right? We don't want to complicate our lives. Should this dependency map also return files? Probably then. But then we have to no, because we want the paths here. Yeah, another special parent that we used is that in Python, the path of a file is the stem of the path of each file is unique. So that means we can't have the same file at 2 levels, but that's fine, because there's another assumption, is that we want our DSPy module to output 4 things, and these are the file names that will be written. So then, even though these may be written in different locations, DSPy won't let you have these as 2 identical field names. So that assumption is fine, that each file name is unique regardless of how deeply nested it's written, because it still maps through DSPy output fields. And that's an implicit assumption that's not checked anywhere. So I guess for sanity checking, we sort of could check that too if we want to, but that's probably not critical. Okay, so this all works. Let's run it. Now the thing is, we want, oh yeah, and okay, so these things go into, sorry, so we have this extra input project, and this is, when you define the signature, this is analogous for AI. It's sort of at compile time compared to runtime, right? So this is ahead of time. So then this meta info is all that the custom adapter needs, and the way we did it is we just inherit from the chat adapter and we overwrite its call to delete this field from the signature, because we don't want the AI to actually ingest this at runtime, okay? And in fact, that, okay, so we don't even need this project field then. which is another good find, right? Because this is sort of the runtime where we actually call the AI, even though the signature, the compile time, tells us we have 3 inputs. That's not really true because actually I think this may have been a mistake here. If we put none, that field, let's see what happens if we run it, because I think that field actually gets created. Again, we use UV, so UV sync all extras. Okay. I guess I must have had something here. I don't even care. And we just do UV run main. Oh no, we have to do the module now. So UV run stream dot main dash dash files, I believe it was, right? Yes. So actually we want to see what happens to the prompt if we feed this none at runtime, because we should not. So depends on. What did I break here? Why? This is a bit confusing here. So fpath stem for each file. We have to build the list manually here, right? G for G in f depends on. And it will be g.path now, right? Because we want to convert this list of files to a list of paths, and we have to walk through all the files and get their paths. Okay, let's double check if this is right. It should be fine. My bad, because we have to, oh yeah, now we have to also redo our data structure here. So, okay, this is better actually, because it allows us to now statically create the files and then create the structure using the files. I think this is gonna end up cleaner, because what we want to do is we'll just create the files here. Okay, so cases. Again, we'll just use their name as key because we know it's unique, and this will be a file. But we end up with recursivity problems, right? Or should we create the files? So basically we'll create the files without dependencies first. Yeah, this feels better than repeating. It's kind of the same thing, but a bit cleaner. So the files without dependencies are easy because it's just something like this. Cases and then all the others. Solution. Test. The only problem is we still need to add, this does feel a bit more organized, but we still need to add memory. Okay, so we have 5 files now, which is accurate for our project, but so which ones are the base files? Files, cases, and solutions. They don't have dependencies, right? Oh, but then we can't reuse the test here. Unless we need a constructor here that returns a new file. Okay. With depths, it's not the worst, right? So we just want, and it returns a new file. And what it does is, so it takes a list of dependencies. And it just returns a new file with the path and depths. It's not the worst, right? This should probably be a class method. Can data classes do that in Python? Data class method. I believe they can, right? Yeah. I see. So it's just CLS. Okay. Maybe this, maybe something like this is cleaner then. This should be a class method. And it doesn't see self, it sees CLS and file. And it returns a path with file.path and depths. Sorry, depends on depths. Because I don't need the graph here anyways, right? Although this does help us. Okay, so then add dependencies. Maybe we do it this way then. I think this is more modular then, right? Because we want to overwrite these files. Okay, so then cases, who does cases become? Nobody. Cases doesn't depend on anybody. Solution doesn't depend on, it does depend on, no, it doesn't depend on cases. Test now becomes file dot with depths itself, and the depths are, we just list them. Okay, this seems cleaner now because then okay, yeah, let's do it this way, right? Because we don't have to, it simplifies the structure a bit, I think. We'll figure out if this is a bad thing or not. So who does files with depths depend on? Sorry, test. Well, test, I think it depends on everybody. Cases, runtime, memory, and solution. Okay, so it's gonna depend on. Interesting, the order does matter here though. This should be built, but how can we build this in topological order? Oh no, but it doesn't. Yeah, the links are going to be broken because test depends on measurements, but the measurements also depends on solution. So I won't have visibility in that link. This is currently built in topological order by hand. Not sure if there is a way actually. Well, fix me. Propagate. So we should post. But then what if we get circular dependencies? Is that possible? It is possible in Python. That's pretty basic actually. So how would we do it? The first module depends on the second. The second depends on the first. Actually, the order doesn't matter there. It's even easier here, right? So yeah, because you just do the first depends on second, and then second depends on first, which already depends on second. So I mean, yeah, it is a cycle in the graph, but it's not of consequence here. But my problem is how do we specify this graph? Can do a dictionary, who depends on who, and then yeah, okay, so use a proper graph library to store this, because otherwise we're gonna have to manually propagate ourselves, and for now we'll build it by hand, build it by hand, which is not that hard because we know that runtime is a file that depends on, so it inherits itself. So we don't want the class method then, right? Well, we can leave this class method, but we also want add depths to self. Which does nothing, it works in place, and it does self depends on dot extend depths. Okay, so then this is easier because it just becomes dot add depths, and what dependencies do we need? The list of all dependencies, which is solution, well, cases and solution, which we reach the end of the graph. Okay, good. Yeah, same for measurement, memory. And then now for test, now we reach the top of the graph. And which was the fourth? Oh, the fourth was solution, obviously. Which test depends on these two and also on these two, which already have their dependencies now. Okay. Yeah, so we definitely need a proper graph library for this because it seems like we're reinventing the wheel. Okay, now the folder structure becomes a lot easier. Okay, so we got distracted a bit, but it's fine. The folder structure becomes easier because the main path is the path. Now the files in that folder are files. We can reuse the files, right? Cases, solution, and test. And that's it. We don't need to specify depends on. These are already done. We'll still end up with more code lines, but they do look a bit cleaner. And the subfolders, it has a subfolder called measurements, which only has 2 files in it. And that's it. This section now only, yeah, this does look cleaner because this section now only tells us just the directory structure. which could be inferred from paths, to be honest. So what we would like folder is to just be constructed from a list of files, and then okay, to do the constructor for this should just be a list of files and paths auto inferred, or I guess directory structure, which is pretty easy, to be honest. It should be like 10-15 lines of code, but pathlib has everything to find common directories and everything. So yeah, I think you can pretty much cluster with pathlib pretty easily. It may even have actually, let's see, maybe we can one-shot this. So build directory structure from file paths using pathlib. Yeah, so we have something. This is clean. We don't even need this. Oh, so we just create the directories. Oh, that's it. Oh, okay. So just p.parent.makedir. And we don't even need exist OK, actually. Oh, wait, actually, this is so easy then. What are we talking about here? Because we just create parents through... Yeah, we should definitely do this then, right? Okay. So what does the folder do? Initialize modules. Oh, we already have this. Oh no, but we need the subfolder. Sorry, my bad. Do we need the subfolders? I don't think so. Yeah, I don't think these have to be recursive at all, right? So what is happening here? This definitely doesn't have to be recursive. We can just take a single list of files. We don't even need subfolders. We have the full paths. We don't even need to manipulate paths. That's the thing. It's not like we're... Okay, so then this is fine. What does dependency map do again? So for each string, which is the stem of the file, gives you the list of other paths, full paths on which that file depends. And this is already known now from... Right, because now the files have dependencies. Yep, so this doesn't have to be recursive either. And file map maps. Okay, I think this works. So we can nuke everything now. We can nuke all the subfolders too. And what is the top level path? Do we even need this path? I doubt it. We need it in files for sure, but we do not. Yeah, okay. Okay, so this can be nuked drastically, which is good. So actually, this is not a folder. Let's call this a project. Well, first and foremost, let me see. Hang on. Before we jump into a big rework, let's see. Git status, because we're doing Git now. UVX rough format. Okay. So let's try to run this first. It's memory, not. Okay, everything works. We have our thingy here. Solution test, yep, all the imports, well, because the AI wanted it to, but the imports look okay-ish. Yep, output solution. Okay, good. So this works now. So let's commit this for now, which is still an improvement. So git add src stream. We change the adapter and the main. Okay. The working copy of. I need to fix this actually. We need to switch to the Unix thing. I think that's what's happening here. From the Unix style. Git is configured to use. Okay, let me try this config then. This seems like something we want, right? Okay. Oh no. Oh no, we want this, but okay, it's good that it happens. Okay, because it just, okay, got it. Because it just changes it online, which is kind of what we want. So we can commit this to be make a project structure more modular. Okay, now we can actually start the bigger rework because we saw that we don't need any of this. We do, sorry. Yeah, this is way easier now actually because first of all, there is no subfolders anymore. It's just, let's just have, and it's not even called folder anymore. It's just called a project, which seems a lot more appropriate. And it has a path, which is the core path of the project. And it has a bunch of files. And then to initialize the modules for each file in files, we're gonna make the directory not of the self path, but the file.path. Do we even need self.path? No, we don't need this either. Okay, so project is just a list of files now. It's a collection of methods, basically. And then we're also going to touch the init. Exist okay is true is fine. We could do if not exists make theirs to avoid some useless folder creation, but it's fine for now. Okay, that's it. So for each file, we touch the directory and the init in that module. Okay, then what? The dependency map. So this is fine. And that's it. We return this now. There are no more subfolders because we have all the files, right? So the stem of each file path is whatever's in depends on the path of that. A list formed by the paths of those. Okay, this looks good too. No more recursive. And same here. Each file is mapped to the stem is the key and the path. This is really trivial now, but yeah, sure. These, I guess these are fine because they're cached, sure. Okay, so where did we use the folder? Because the info is now a project, not a folder. And that's it. Okay, and then info dependency map is fine, file map is fine. That's it, we just used it in 2 places, and now this is a project, okay, which doesn't even have a path. Well, it's just files now. Okay. This looks a lot cleaner. Aha, and we can't call it, right, so project structure, which is a project now. Yeah, it has this description, but here's the trickery I wanted to see. What happened in what we ran here? Oh, I see, sorry. So we do not need this. Okay, good. There's one more simple, okay. So let's see, UVX rough format. Okay, so this should work the same now because we didn't do anything material. String attribute has no attribute path. Why? For f in self.files, that looks sane. F depends on is also a list of files. But why f.path? Because it's a list of files, right? It doesn't have any... What? Are these not my files? Let's see. Mapping. There. Yes, there. Something is fishy here, right? Because files should be proper files, and they are. Oh, sorry. It's a list of files, not... whoops. So it's list files.values. Yeah. Okay, so we also have the mapping for free, to be honest. This is the mapping between name and... The mapping between name and path is trivial, but yeah, sure. We'll get it here again. I mean, we could get it on the outside, but then what? So what's the advantage? Not too much, it seems, right? So we can just leave it there. Okay, this should be fine now. It seems like it's using the AI. No, it does not work. Project structure. Do we even have an initialize? Oh, we do have an initialize module. So okay. Here we go. Okay, so we open the file map. I think this is good, right? So the file map has remained intact. We just write the code there, and there's one special case where, yeah, this should be fine too. Let's see. Okay. We messed up because the folders are wrong. Okay. So not make dir's file path, but rather we need to make the parent directory of this, right? Dot parent. I believe so. Right. Let's see. So UV run Python. From path lib import path a equals path of a b c a well, no, it should be like dot sum. Okay, so a dot parent, yeah, this is what we want, not the file. Okay, UVX rough format. This should really be it now, so we can finally move on to the items. Okay, so we have AI right for us. Let's see. Okay, this seems fine, right? So the cases we wrote, there we go. The test code uses the right import. Let's try running the test code that the AI wrote. It should have all the right imports now. So I can do UV run, output, test. Sorry, I have to be in it, right? UV run test.py. No, why? Actually, no, I can be outside. Why can't I run this? Why won't this run then? Oh, is it the measurement that has the wrong code? No. Output.solutions. Output.cases. Yeah, these all link fine. This is definitely a UV run issue. It's -m output.test. Yep, there we go. Okay. Now what happened here? The test itself failed, but that's a different story because the AI is not smart enough to actually solve the problem, but we can try again. We can regenerate. Okay, so you have to run the module with UV run -m. That's good to know. Yeah, we're gonna need this actually. Okay, so then I can run the test module. Interesting. It's hallucinating. Okay, so we're at the point where the AI is now, let's see, so import cases as get cases. The AI doesn't know how this is written to so we have a special problem here because the input, there is no code associated with cases at all. The AI doesn't know how we write this to file. Okay, anyways, this is not an infrastructure issue. So UVX rough format should be good. So let's see, what did we change again? Adapter. Okay, anyways, a bunch of changes, looks good. So, and we changed the main to, so we can say git commit -m simplify project data class by a lot. Yep, we gained a lot. we are good now. We also hit an interesting corner case in that the AI doesn't know how we write the code. I think here we have to manually prompt. This array will be written. No, but this seems dumb, right? We should just use DSPy Python code then. DSPy code Python. But then we lose the list, we lose the type annotation. Interesting. I think we should leave it like it is because this is an interesting mix of sort of three things. Strings are strings, code is code, but there's data, there's like raw data being passed to an AI model, but then the code in the background writes it to a Python file in a certain way. So maybe this needs another adapter. Okay, this is not a bad thing. Let's write this down. Huh, interesting. So maybe this needs another adapter. So we can chain two adapters, which interesting. That's a good question. Can DSPy chain two adapters? I don't even know that. But the point I was going to make is that we want to write another adapter that adds an explanation input signature field for raw values that get written to code in a certain convention. So this adapter would have to take that convention in and write a small prompt that tells the model, hey, this input will be written. So maybe it either, that adds an explanation for raw values that get written to code. Now the question is the explanation a new field or a modification of the signature? I feel like it's not a new field actually. It should just be a modification of the signature fields of the signature field that contains raw data. Because I was about to do this by hand and I kind of stopped myself, right? This is actually a pretty nice find because I was literally about to do this now. I was about to type a small explanation here. This will be written to a Python file, to be more accurate, in a certain way. I don't know what I would have written, but then the thing is we don't want to write prompts by hand, right? That's kind of the point. We should rather think of writing an adapter. Okay, so pretty good. This can be a future topic. And then how do we use this adapter with what we have today? That may even be pretty tricky in itself. I'm not even sure No, I think it can, right? Because it just changes the prompt. Interestingly though, the adapter we wrote sort of doesn't change a prompt. Let's see. Yeah, it calls a format method. What is call process? Huh, interesting. I wonder if modifier adapters are a thing in DSPy. They may not be then. Interesting. So what, I can't modularly change? No, that seems like something very, very important, right? Okay, but until then, so that's sort of an alternative way to fix this problem. Until then, let's go back to what we want. Finally, we can go back to what we wanted to do today, which is add code execution feedback. And for that, not that easy either because, well, it is easy. Fundamentally, we saw how we do that. We just ran the module. Yeah, so let's assume for now output.test is universal, right? So we always do uv-run, uv-run-m output.test. That's it. Okay, now whether the AI fails, let's try to get the AI again. I think I know we got it to work last time, so it has to do with luck and how it imports that array now, apparently. Although we do tell it, actually, that we do give it instructions to use from cases import. An interesting thing happened that it did not output the solution at all. Sometimes this happens with DSPy too. Okay, there are other things we have to do though. Let's work on some other small things because this looks really bad, right? Well, how we would like this is we would like to be triple or a code fence Python and then a new line and then also Python, because otherwise the raw prompt that goes to the model looks really ugly, all right? Yeah, should be how it looks like. This is gonna cost a few more tokens, but we want this. The second thing that happened is that sometimes DSPy doesn't obey the structure, and in this case, not quite sure what happened though, because we do see the history here. It was not able to extract solution, expected to find output fields in the LM response. I see the field here. Oh, this tiny space here. Huh. Yep, the DSPy is not robust to this space here. When they detect the fields, this is what happened. Pretty interesting. I have not seen this myself. But my question is, why the heck am we seeing a history that's valid here? Because the adapter didn't finish. Okay. Okay, interesting. So that's a DSPy bug actually. Well, it's not a bug, it's the model misbehaving, but it's misbehaving in a way that is not recoverable even with feedback in this case, because it's a DSPy library issue, not okay, so now the generation worked. Let's fix the code fences though in the yeah, I feel like we want that, right? Because it looks pretty ugly, to be honest. Okay, let's fix the code fences. So, what do we need to do? Well, we need to go to the adapter, and it's pretty easy, right? When we format the output interactions, we just forgot to add, first of all, where do we add the output? Here. We have a language too, which we should use here. So, generate use statement. So if this is the first dependency, we want to add, I guess we'll have to get this, we'll just enumerate this, right? So if I is 0, then we're also going to add the opening language dot lower, I guess, right? /n. Where's my language? Oh, I see. It's the fields here. Yep, it's the language of the field in lowercase. Opening backticks, and then if I is length, well, actually, we can add this always then. Wait a second. Oh, sorry, we can just add it here, right? Yeah. Okay, so then we open here. And then we also need to add closing fences or close. Yeah, no, closing fence. Which just says a static output plus equals. And we also want another new line here. /n/n. We don't need the F. That's it. So now our prompt should look a bit cleaner. Really need to automate removing this. Yeah, let's remove this. Remove recursively. No, let's not do that actually. It's even better. Let us just take this as an argument, the project name. You know what? That's probably better, right? So this should be args.project name. And then we can just take an argument. Project name. Oh, I believe it's called type string default. Here output. Location for the LLM to write code in. Okay, so then we can just run this again. Ooh, because I don't have all fields here. So how do I get the language? Okay, I just need to switch the chronology here a bit. Yeah, this looks cleaner anyways. And we don't need this. UVX rough format. Good. Okay, everything looks good. Let's see, how does the prompt look like? Okay, it looks a bit more organized now. It says when generating code for runtime, use the following import statements. It's Python code. Now, this is what happens here. It's from output cases import. We're misleading the LLM with function name. Yeah, we need another another adapter is going to be tricky here because this is already written. So how would it know? Yeah, I can see now why multiple adapters in DSPy are a problem, because so maybe the other adapter, yeah, okay, it's not made for this. Okay, let's see, does it get lucky and does it use, yeah, from case import cases. In this case, it gets lucky. So if we just do dash minus uv run dash m output.test, this should, so test is hallucinating. Wow, but even runtime imports itself and mem usage imports itself. This is pretty bad. Yeah, so these are actually extra imports. We did not ask for this. They're also hallucinated. Yeah, these are fine in test actually, but these are not. So yeah, okay, good. So we're dealing with practical AI problems now. So let's fix this. Okay, good, perfect. So this is what test execution is gonna, execution feedback will fix for us, hopefully. Let's upload what we did though. React's rough format. Okay, and what were the changes? Because I kind of forgot. SRC adapter. Oh, okay, I see. And in main, why do we change main? Okay, so we can add, we can just commit -m. Oh yeah, there's a. Okay. Add argument for project name. Okay, and then we also want to commit the other file, which the changes were prettier instruction, import instructions. Okay, now we need to do the real thing now and get to work on code execution feedback. Write the new DSPy module capable of ingesting feedback. It could be DSPy Refine. So let's take a look. Let's take a quick look at what DSPy Refine does and why it may just work. Maybe not though. Yeah, refines the module by running and returns the predictions. Module runs provided module multiple times. So we can use a binary. So this is a module that you just give it a score function and it selects either the first prediction that says the threshold or the one with the highest reward. In this case, we can have a binary reward. Run the code, it gets a 0 if the code doesn't run. It gets a 1 if the code does run. If no prediction meets the threshold, it automatically generates feedback to improve future predictions. This part I'm not familiar with. We can also try the more basic best of n, which just blindly retries. But it doesn't have feedback though. Yeah, we want refine, right? After each unsuccessful attempt, except the final one, it automatically generates detailed feedback about module's performance and uses this feedback as hints for subsequent runs. Okay. So I guess we could use DSPy refine. Let's take a look at it though, because it may be a bit too complicated for what we want. Oh yeah, I know why it did. Okay, so it should be in predict, refine. Okay, interesting. Can I not see? Okay, I can see the code. Right, so this module has another signature. Assign blame to each module that contributed to the final reward being below the threshold, if any. Then prescribe concrete advice. The module is not to blame, the advice should be NA. When they say program, they mean the... Yikes, but this is so much, it's so verbose. So this is a pretty complicated DSPy module, to be honest, because it has like what, 1, 2, 3, 4, 5, 6, 7, 8, 9 inputs, 2 outputs. The code of the reward, the target threshold, I see. So it even takes a float. Why does it need this? This is so confusing. Like, why would you need a target threshold? Oh, because it's all AI based. No, it's not. It's just, okay. Well, I don't see why you would need a target threshold, but yeah, sure. So this can go. Why would you even need the reward? I guess you need a reward value to enable reward seeking. In our case, it's binary. So what? It tells the, yeah. What is module name? Name predictors. Program. Inspect modules. Is name predictors a core DSPy construct? I think it is, right? So what, each module has named predictors? It does have it, okay. Oh, it's just, oh, it actually means just the predict method. Wow. If it's in the name parameters and if it's a predict instance. So what, refine doesn't work with chain of thought, for example, or other core? I guess not, it's not made for that. Yeah, this is kind of why it's definitely a weird choice, I will say that. And it also wants the program code, self-module code, which is what? Oh my god, it's actually the source code. Oh, but I see it does work with predict because chain of thought is also, I see. So everything in DSPy boils down to predict, basically. Well, no, that's not true. Wait, does, oh no, yeah, it does. Okay. I see. So maybe, okay, so predict should be fine. So maybe we can just nuke some of the fields here. Yeah, I think so, right? We want to nuke this a bit. Like, we don't need the threshold. We don't need the code of the reward function or the program. What is module definitions? Inspect modules. The signatures. So it has the signatures and the inputs. The trajectory tool, which is manually built from a trace. Which is actually a core DSPy trace. Do we need a trace? Wow, it's also a giant try. And the module names, which are also very weirdly placed last. It definitely feels like somebody's changing these without... Yeah, we want to clean this up, right? So this is not a bad thing to do, but we definitely need the previous outputs. So the program outputs. The thing is, these should be explicit inputs, like they just dump them all in once. So how come program outputs gets passed? Okay, only dumps if it's, I see. So they take the dictionary and they also write it to JSON. Yeah, this seems pretty complicated. It's intimately tied to JSON formatting then. Okay, let's do our own thing. Because this looks... So if I have multiple previous outputs, now they become inputs. But I can also attempt to run each of them. So then I have a doublet, right? I take each output, I attempt to run it with uv run -m, which I can generate systematically now, the instruction, the command, which is actually exactly the conversion we did in the adapter. So I know how to run each Python module. That's specific to Python, but it's fine. So I attempt to run each output, I collect Python errors, I suggest some feedback with the DSPy predict, and then I collect feedback in a new field. So we need signatures with dynamic. We need to create a signature whose fields, I think I'm gonna do it with, instead of doing it the JSON way, let's just, so what we want to do is, okay, we'd like to have solution out attempt more fields, right? So this is what was attempted before, right? So the previously attempted solution, should it be missing if it's yes, that can be a runtime thing actually, right? Because fields can miss from DSPy inference. Oh, that's a big thing then. No, I think it should always have an outcome, right? And then it should also have solution outcome. Okay, this is not DSPy code now, this is string. Oh, sorry, and these are now input fields, right? Input field, DSPy.input field. Description will be the outcome of attempting to execute solution. It's actually solution attempt. That's the correct way. And solution feedback. Feedback for fixing solution if it previously failed. If not, this message should say do not change it. Okay, and then we want 3 of these guys for each output. Okay, so we also want a runtime attempt. We also want a, well, runtime, I'm not gonna write all of them by hand, but the idea is that can we write these fields systematically? And yes, I think so, because you can add, this should be pretty easy, right? You can add new fields to a DSPy signature. So let's take a look a bit at signature. With instructions, no, with updated fields, Insert a field at index 0 of the outputs or inputs. Append. Insert a field at the end of the inputs. Okay, so we just insert fields. Insert a field at specific location, compare JSON schema, dump state. That's it. So we just need to insert fields, append fields at the end of the inputs. The order won't matter here because these will appear. Okay, so they should be here, right? There should be feedback fields. There we go. So we just want to, we're going to have a double for loop, right? So for each output, that is code. Okay, because if it's not code, it can't be executed or we don't yet know how to handle it. For each output that's code, we're going to append 3 new input fields. We know the name because it's just this underscore attempt outcome or feedback. Okay. The field is input field. Oh, okay, and I can just... Oh, I see, it's actually an instance, so I just write it here. And type, I have to annotate it here too, right? It's these 3 types in fixed order. So attempt is code, outcome is string, feedback is string. Okay, that's it. This is pretty easy. And then we write, and then our module attempts to run each of the fields that are code, collects all the feedback, places it in a dictionary just the first time, and then the second time it also takes the past, and that's it until we see a special success field. So we need a special message here. If the feedback, okay, we're not gonna, well, we can just have the outcome be a float then. Solution reward. There. So then if all the rewards are 1, then we can deterministically stop because we know all the code that the AI wrote is runnable. Pretty good. Okay, let's take a break and we'll do it when we get back. This should be pretty good. All right, we're back. Yeah, so let's do it this way, because the other way I was thinking it's sort of not that there's anything fundamentally wrong, it's just a design choice, but this really looks like indirection if you think about it, because instead of modifying a module to have new fields and then retrying the task with info from the past, the way they do refine, so whoever uploaded this, it acts like an inspector, right? Like it says, here is what was attempted. Well, here is what attempted and what was attempted. Suggest a fix for that entity. And then that advice is taken and passed to the So actually, what is it done with advice? Aha, there's even like, there we go. This is the thing. Aha, this is what we're going to do. Okay. So they do also change of course, they must change the core module to also take as input hint. But see, they do it for each. Yeah, they do it. Interesting. So they actually do it right on adapter. Yeah. This definitely feels like indirection to me. I feel like you should just modify this module once and for all in the init. So it has the hint and the past attempts instead of them being here and the scores, and then just keep running that in a loop. Possibly building trajectories if you want, sure. I guess there is an advantage here because they only use the trajectory for the advice. So do we want to keep trajectories? Yeah, let's keep full trajectories. By the way, this is much closer to what they call React, where they keep trajectories and they changed they write a new signature in a new module. Yeah, so we'll do it the React way. We'll do it the React way, but closer to the refine way. I think this is the cleanest way, yeah. Otherwise we can't just use refine magically. Okay, let's push it to the limit and let's do a trajectory. So I also want to see if I do a list of code. So then the past attempt is not one, but it's a list of code snippets. The previously attempted attempts for solution. I guess it will be the latest solution attempt, the latest of solution attempts. And the feedback sees everything. Okay. Feedback, the feedback we also need statically. Okay, so let's do it this way. So then we go like this. We do, so we're gonna need a new file, which will be called feedback.py. So we want to import DSPy. And we're going to write a new module. And it'll be module with feedback. DSPy.module. Okay. And the init self super, what is it? Yeah. This is how you call super, right? Yeah, oh, I see it super like this, okay. So first of all, to initialize this, we need a module, which is a DSPy module. Okay. Do we need a signature or can we extract it? I believe we can extract it from this, right? So if I look at predict, yeah, they all have signatures, right? Okay, so then we can say self.base module is base module. So we need a base module. We also have a base signature, which is base module dot signature. I wonder if all these have a signature. Surely, right? Okay, I see, because it wants named predictors. So chain of thought doesn't have a signature then? Is this what this means? No, everybody has a signature. Even refine has a signature, right? Well, no. How do they get the signature? Predictor.signature for name and name predictors. There is a problem here. If I have a module that has two. Okay, I understand why they did it here. So signatures. Okay, so let's do it. Fine. So base signatures. But then how do I patch that signature? How do they patch it here? With an adapter. I think this piece of code we need then, right? So, because we want to patch the signature, even if it was only one predictor, we still don't know if it would be predictor chain of thought, so we can't just magically, and we're not gonna manipulate. I guess we could reinstantiate. So it's not quite React style then. Let's do it properly then, right? So if not advice. So the first time they just run it vanilla, and then they patch the signatures. Yeah, we need this. We definitely so we have to do it for each mod. And where is the for loop for modules? Try with DSPy outputs, class wrapper with DSPy context outputs mod. Because it, oh, I see, but they do get the adapter. Oh, this is not, oh, no, this should be good because we have an adapter, right? So yeah, okay. So our adapter is the custom one. Do we have a custom call method in our adapter? What's happening here? Ouch. Ouch, we do. And what do they do? Oh no, then they just call the vanilla call, right? They could have used super.call, yeah. Well, no, not, yeah, it is super.call, yeah. They actually call the adapter. This is also at runtime, which makes sense. Okay, so pretty useful things here. So define forward. Yeah, we don't know what this is, so it'll be generic, and we're gonna have to get the adapter. Because if it's none, okay, yeah, this, they should fix this, but it's fine. It's not too annoying. We don't even need, yeah, we want to collect the base signatures, right? So module.signature for module in self base module.named predictors. Okay, so we have all the signatures. So we just we can statically modify to include previous trajectories. So who gives us the advice in our case? I think we have to just we don't need two of these for code, but yeah, let's do this for code, because code we can only, is there any way we can actually avoid that? I'm starting to understand why they did the indirection now. You can get the code error, so we can get the Python error message, but we can't really get feedback. Not in the same. It'll always be delayed with one step, right? So if something fails now, obviously there's no feedback in the first step. So outputs code and it fails execution. Unless you actually use AI in the middle, just on that error to get the feedback. Yeah, there's no other way. So you need an indirection there. So let's not do that because we want this to work for code. So then we know we can get error messages. And let's assume that most programming languages will be quite verbose. That is different than advice, but it's implicit advice. So the model should be smart enough, or we're sort of putting an extra burden on the model. We are improving latency though, right? Because we won't go through this indirection. Yeah, so this will be execution, because so we were gonna do this on all code outputs, right? Actually, we can crunch this then because we just need a reward. Outcome of attempting to execute the latest of the attempts. Okay. Yeah, so we're gonna need a sort of a special message. I guess it can also be a, oh, is it a float? No, it's not a float. It becomes a string now. So we can call this outcome. Okay, and then if it executes successfully, we'll have to output a special message that doesn't collide with any error message in Python or in any programming languages. Something like code has, it's not even executed, but or valid code or something, because some languages our code has executed, others our code has compiled. So maybe DSPy code also needs a compiled or interpreted flag, but that's another issue. Yeah, so we're down to only 2 fields. Okay. And then we'll do it this way. We'll modify all signatures. Yeah. Okay, so let's do it more simple, right? So we'll modify all, let's not do the indirection. To include trajectories and execution feedback. Okay, good. So self dot, so for field in, well, no, for signature in self. Okay, so for field in signature dot output fields. So in each signature, we want to only look at the output field, only for code outputs. If not, how do we check if something is code? I think we had something here, right? We had something in the adapter with the language thing. This is wrong. We could not get the, which reminds me, this comment here is wrong because it's all a single model call and it all comes through the API. We cannot infer use statements at runtime. So that's good. Oh, here it is. Get attribute bases none is code. So if it's not code, so if this field is not code, Okay. So if the basis attribute for the field annotation is not called, then continue. If it is a code output, and it's an output because we're already in output fields, then we're going to do mod signature should we do a deep? Do they do a deep copy here? Yeah, they do a deep copy. Yeah, there's also an attempt loop here. So for each attempt, so we have steps, which is an integer, which is, I guess, 3 by default, right? So we do like self steps, or I in range self steps. So we're gonna attempt inference 3 times, then we're going to do early exit on all success, and that's it pretty much, right? We're going to return pred. If all, I'm just gonna write some boilerplate logic here, break. Okay, because we have the pred. Yeah, so we're gonna need this. So we're gonna need to monkey patch this, these signatures in. But first, let's create them. Do signatures have copy method? That would help a bit, actually. So, I don't know if they have it though. So we can just copy here. Let's see, DSPy signature. Well, even if they do have it, it's still it's basically the same thing, right? Might as well. Might as well deep copy it ourselves because it's still a deep copy. Okay, I'm just gonna deep copy. We're just gonna deep copy it ourselves then. Seems like there's no deep copy. Okay, so we have our new signature. And we're gonna store them here. Aha, but how do we know which is which then? This is gonna have to be a dictionary from a string to a signature. But it's not really signature instances, it's like class. How do we type annotate a class? Oh, type. Type. Okay, so it becomes from typing import type. So it's the class. Oh, is it like this? Yes, it is like that, right? Yeah. Okay, so so then this, the signature itself, okay, and okay, this has to be also like this, right? Yeah, we need these to be dictionaries, and they become dict, and they're gonna map their name, module name to module signature. Oh, whoops. There is already a name. So it's a list of tuples. So then what does it want? So we have to see how they do it and refine here. Yeah, it is name predictor. Okay, so it's for name module, and we go name to the signature. Okay, so the base signatures is the dictionary here. The mod signatures is also this, but empty. And we deep copy the signature. And for the output fields, for those fields that now here's the trickery, because we have to insert, oh no, we're gonna insert these as input fields, right? Yeah, okay. So we're going to do, sorry, let's work on mod signature, right? So we're going to do mod signature dot append, and that's it, right? This is what we had. And this is a these are all class methods, right? Yeah, they are class methods, yeah. So then we're going to append. Oh, nice, I have visibility into it now. Insert a field at the end of the inputs or output section. The name will be field dot name underscore, what do we call these guys? Attempts. Oh yeah, this is a list. Okay, and the field itself is a DSPy input field, always. The description is what we wrote here. The previous attempts for, except this is not solution, it's rather field dot name. I really hope it is name. Okay, and the type, wow, the type is tough too, because what does it want with the type here? If it's none, oh no, I'm at append. Is resolved by insert. How do we, where is insert? Type. The field's existing annotation is used. Okay, not sure what. So I see. So you have to carefully set the type of this thing. I guess this. Oh yeah. So we need to get the language here, right? What field dot language, because the attempt is a list of code. Rough. This looks pretty rough, but it's not the worst. It's not the worst. We'll see if this works. It looks pretty ugly though. So here we insert the trajectory field containing all previous attempts, possibly truncated. Okay, so let's also have a parameter called trajectory, which is an integer, and it's -1 to mean that it's not truncated. Let's call it trajectory length. -1 is bad, but let's do it this way. If self trajectory length is none, self is infinity an integer in Python? That's what I'd like to know. Python infinity integer. There's no Python. Damn. How do we represent an infinite trajectory? Okay, let's leave it as -1 then, for now. Which is pretty ugly in itself, but it's fine. Okay, so the trajectory field containing all possibly truncated previous attempts, it will always be a list, so it doesn't really matter here. And then we say insert the execution feedback from the latest attempt. Okay, so then we do mod signature. We also append to this. So what do we append to this? The same thing. The name, except now it's called feedback, right? That's what we said. Oh no, outcome. Okay, execution outcome. Okay. And code execution feedback. Code execution outcome. Okay, the name is this. It is also an input field. The description is what we said here. Outcome of attempting to execute the latest of, in this case, exactly this thing. All right, so field name underscore dot attempts. Okay. And the type is easier here because it is just a string. That's, yeah. And we're done. Okay, so now we can leave this intact. No changes here in main, not yet. Let's rough this up a bit. So UVX rough format. Okay. So yeah, an input field. Okay. That's it. So now we have 2 extra input fields for each output, for each code output. Okay. Now the forward is the tricky part, because we also actually have to execute. Don't forget, we have to. Okay, we're gonna need a sub process. We're gonna have to actually execute code using a run command. Oh, so that means this guy also has a language, which is a string. And by default, let's say it's Python. But we would like this to be generic, and it will also have a execute code. Okay. So let's say it takes self, and it takes the, what does it take? What is a concept that works both for Python and for C and for Rust and for Java, for all programming languages? This one is tricky because it's, even in Python, we're using the module run. Wow, so does this need visibility into the whole project? Which doesn't have the language, by the way. Which seems like something needed. So a project should also have a language. That seems like a good thing. Tricky. I guess we can pass it here, but well, let's use the similar templating we did here, because yeah, we'll just have to take the language in. But okay, we take the language, but what do we take also? It's not the file path, is it? I think module name is the most universal thing I can think of. This one is really tricky. But it's as tricky as this one. The question that I want to ask is, could AI figure this out? Because that's what we talked about last time. We want to get there eventually. We would like AI to write, else if language.lower is Rust, something. We're not going to be able to write all of these by hand. But we'd like AI to write this for us. But this does raise issues here and in the feedback. We have a location. The funny thing is, use statements do seem a bit easier. Execution is a different beast though. Because in C you execute a target, you don't even execute a file, or same in Rust, you execute or an executable or an artifact. So let's call it artifact path. Okay. I think this is pretty universal. PQRST from path lib import path. So then we want to say exactly like we did in the other place. If language.lower, if we're in Python, the artifact is a module. So the command becomes uvrun-m output. Well, no. Yep. Yeah, it's a path. It's the path to a module, which is a valid. Yeah. Okay. The path, the artifact is a module. In C, the artifact is a target. In Rust, it's a target. Okay. In MATLAB, it's a script. Okay, this could work. Yeah, we have to use UV. Yeah, that's it. We just UV run -m the path to a module. We have to be careful how we build this. We don't know how to call this function yet. So then we just run it. That's it. Else, we have to raise the same error. Okay. Execution command. Okay, so now we're seeing another pattern, which again, we want to get here eventually, but this one's gonna be trickier. We'd like to also write AI modules that generate these things for other languages. Okay, so once we have the command, execute the command. This one is easy, right? Because we do, let me see, subprocess.run command. I think that's it. So success, error, right? This gives you standard output and return a complete process and returns to have attributes, return code, standard output, standard error. What does this give you? Oh, it's a completed process. Is this a new thing in Python 3.14? Interesting. Result. Let me try this. Pretty interesting. Or am I making stuff up? So if I go to Python and I say command is UV run -m, do I have the output here? I do have the output. Output .test, okay? And I do import subprocess. And I do result is subprocess.run command. Okay, but okay, it just prints to but we need to capture these errors. What is happening here? Well, that's, I see, capture output equals true. Okay. Interesting. I didn't know they organized it like this. Capture output equals true. Okay, so what do I have in result? Okay, args return code. So if result return code is 0, this is success, right? So the execute code returns a string. So we need to return the special message, which is code successfully executed. We have to remember this. Else, that means the return code is non-zero, so then we can get the error. Oh, and we can just return the error, right? Return result dot standard error. Yeah. Okay, and this goes to the LLM. Interestingly, this is a bad message here. Cannot import name time it. Most likely due to a circular import. It is not due to a circular import. It's because that thing does not exist. Oh, it is a circular import. Oh, yeah. It is a circular import. Never mind. I'm not even sure what happened here, actually. Yeah, it is it's also a circular, but it's also an invalid. Like, this is not even defined. Interesting. It's pretty bad AI hallucination, but this is the point. We're going to fix all of this. Okay, so then we have our code execution, which gives us I guess we can call it a success message too. Okay. So then we return the success, which has to be something special, but it's fine. Okay, so we have our code execution routine. Pretty good. Now, let's go back to the forward. Oh yeah, we get the adapter. Monkey patch. The new signatures. New signature fields. So do we do all these signatures for nothing? I think we did do them for nothing, right? Because refine, the way it works is... Well, no. We can just retrieve this. Okay, I see. So we don't have to... I see. So here they monkey patch it at runtime. But this is... Okay, we do it more elegantly. There may be some sharp edges here, but I think it's fine for now. So yeah, we still need a new adapter. So class is... what do they call it? Feedback wrapper adapter, okay, and it does inherit the class of the adapter, and we just override the call, which does eventually call adapter. What do these things return? The calls, are they all list? I believe they should be, yeah, okay. So we're gonna need to type annotate this too. Whoops, here. Call self from typing import any, okay. So then we want this adapter to eventually just return itself. So we do lm quargs signature demos inputs, and then these guys, they just pass through. Okay, we're not gonna type annotate all these, it's fine. Inputs. Okay, so this does nothing now, but what it should do we need to monkey patch the signature. And the inputs. So adapters want both inputs and signatures. This is a good chance to learn about this too, actually. So why do they want both? Is the signature not enough? Inputs, the current input values. Oh, no. These are the runtime inputs. Gotcha. Okay, of course. We need to populate these. Very important. So then these have to sync, right? Hint. Ah, okay. So this is where we execute the code. Execute. And we're always one step behind here. Because we try to predict everything at once. So we put it in the signature, but can we do it? We can change the order here. So what does the call of an adapter do? It doesn't actually call the module, does it? we have a causality issue here because... Oh no, sorry. So this is not where we execute the code. No. This is where we pass in feedback, pass in past execution. No, we're fine, right? So we pass, yeah, because we execute the code here. Execute the code, right? So success is execute code. Now we're gonna have to figure out what to pass for the self.execute code. We'll figure out what we need to pass for. Let's see, how do we execute the code here? Artifact path, language, self.language. Okay, that one is easy. Artifact path though. For each code output. So for output in pred dot yeah, so we're gonna have to execute here, and it'll be I think we actually do need the project. Yeah, this has to be project where. Okay, it's not the worst. Okay, so project. Yeah, this makes sense for a module that needs to work with code. It needs to have visibility into the project. But let's import it for now. So from stream.adapter import project. Okay, so now we have full-blown project info. And also let's add the language here. I think this is needed. Yeah, this is needed for sure. And well, okay, fine. We can have it be Python. Okay. Nah, we should not have it be Python. Let's just add it and we'll create a project. So files and language. It has to be user specified, right? So Python. Okay, good. So might as well be capital P because we want to be consistent with. Okay, so now we can use the language here. And we can also add it as an argument. Type string default Python help the language for the desired LLM output code. And we can use it here. The question is, do we use it here too? I think so, right? No, there may be some trickery here. I wonder if these can be dynamically evaluated. What is this too? Code type. Let's try it. Replace. Do not replace. Okay, so we did a bunch of stuff, but let me try running this again because I want to see. Well, no, we're not gonna do this thingy here. Asking to get in trouble. Does the code still work? It should work. Yes, it should work, right? So we want to remove the output. Ugh, I really need to do this. We should randomize that. Yeah, I think I know what's happening here. Oh, no. Sorry. Oh, this is easy, right? It's the adapter thing. Gotcha. So language has to be first then. And then we should change it here too. Okay. Pretty easy fix. Seems to work, but I want to see that history. Okay. So is it Python code? Yeah, it is Python code everywhere, right? Yeah, code Python. Okay, good. So our language is now parameterized. This Python here is fine because it comes from the adapter, which is already under the Python branch. And I guess he wants... This is, something is off here. Why am I seeing JSONs now? Let's go back to... something is off here. Ah, why? Okay, so there is a nasty sharp edge here then, because if I do, wow, so I can't have a dynamic thing here. I think I've hit this before. Nah. Oh, it's just, what, it's just disobeying? Seriously? Is that the thing we're doing now? Who is telling it to, oh, something is instructing it to output JSON and what? Yeah, this, no. No. Oh no, it is code, but why did it not extract the code? This is so confusing because this is... So what does it write in this case? It still writes the... writes the correct thing. So the adapter works both ways, either with JSON. Oh, I see. So it works. Wow. Really? Chat adapter? JSON? Provides automatic format fallback to JSON if the fails. Use JSON whether to automatically fallback if chat fails. If true, an error occurs. You have to retry using JSON adapter. I see. So you're telling me if I see the history of the last 5 calls, I should see a failed attempt and a fallback to JSON. Okay, this is good to understand what's happening behind the hood because it is a bit sketchy, but sure, okay. Well, here it worked, I guess, so try again. Okay. I guess here it also worked. The value must adhere to the JSON schema, type object, properties, code. Well, who is adding this? Okay, I think I know what's happening here. Yeah, okay. So there's conflicting instructions here. This is a, I know what's happening here. There's a conflict here in DSPy between output fields and the code type. Oh my god, okay, this is pretty bad because, okay. It's fixable, but okay. Okay, so this is good to fix in DSPy. Okay, good. So anyways, so let's see, what did we change here? We changed the adapter, we made the modular to language. Okay, this is fine, so git add. Adapter, src stream main, okay, and we say make language modular. Okay, we're back to our thingy here with the feedback now, because this is a completely new file. So basis mod signature, execution commands not yet implemented, pass in pass execution. We were here. So pred has. We'll have to see, I guess it's keys, right? Okay, so now we have a project though, which is pretty important because we can store this project. Equals project. Okay, so the project will tell us, if we remember what we did here, there's a file map here which matches, this is why, because it matches the output field. So artifact path is first file map for this output, but it's not enough. We have to actually reuse this conversion thingy we did here, because when we do UV run, it has to be Python module syntax. And actually that should be inside the, okay, good. So artifact path, okay. Language is self.project.language. And the success message is self.success message. Okay, so we need this one too. Message string is code executed successfully. Okay. All right, we're getting there, because now what we should do is be very careful here. Actually, this should be a path then. Oh, it is a path. Okay, good. So we need to convert this to artifact name or module name. Okay. So how do we get that? We have that already, because what we have to do is we have it. right here. It's exactly the same as the use statement from this. Here it is. Parts. So, so the AI, if the AI can do that one, it can do this one too, for sure. So the module name is something like this. So we split it in parts. This last part, we remove the extension from the last part. Yup. Which can probably be this. I don't know what. Yeah, we should do this, right? I don't know why I need this module. Yeah. And the module name is just .join. Yep, parts. There we go. So UV run -m module name. So the execution command is extremely similar to the import, which for Python it makes sense. For other languages, TBD, AI will have to write. And now that I think about it, something smart to do would be to use, let me add this to the list, write a single module that writes code for use statements and execution commands. Yeah, this also makes sense, right? We would like AI to just, we have to use DSPy, otherwise we're not gonna microservice everything. Good. Okay, so we have our run command, we have the result, the monkey patch, the new stick. Where were we? Oh yeah, we were here. What do we get here? So message. Okay. Now this is the message for this output. Oh man, which has to be routed. Okay, so let's do a messages, right? Which is a dict. And we're just gonna store messages for this output message, and we'll say if message is not self. We already know this has failed, so we can put all success is false. If everything goes through, but then we should log this. So if this output failed, we want to, this is what would be called advice, what Refine would call advice. Okay, so the advice for this output becomes the error message. Else the advice for the output, we still have to populate this, because in case of a partial failure, some outputs may work. And then we also want to say a special message here, which is this code has executed successfully. There's a modularity question here, because if I write feedback and should not change, this may be a trap here. Or is it? Considering I'm in a hierarchical project, I can get reward. We can get reward hacked here, right? Yeah. Let's keep it like this. Okay, so then we can just take the message always, right? There's no need for two custom messages. pass successful message in case of partial success. Yeah. So for now, let's not, so we can just, we can manipulate it through here, but I guess we should not say do not change the code. Although it is pretty tricky. If something runs, and assuming we have all the import statements, which is kind of the goal of this project, then you would think that you don't want to change that code ever. Which brings us to another aspect of AI usage called for codes like static code analysis, which we could also do here, but that's also for a later date. Okay, so if the code from this field executes successfully, we want to tell the model that. If not, we want to tell the LLM what the Python execution error was. Or if we're in another programming language, which we'll have to write in the future dynamically, whatever compilation error or anything that's wrong with the code. Okay, that's good. So now we collect all the advice and we just need to pass it in now to the next model call, okay? So now we have our new adapter, which takes the runtime inputs. Okay, so we'll monkey patch the signature first. So it'll do this first. So we need to add new signature fields. Let's add the new signature fields because we want the model to be aware, or we want the DSPy signature to include feedback fields about code execution. So we're gonna have to take from, we're gonna crib from refine here. Oh no, sorry, we have this signature. Oh, never mind, sorry, it's easier for us because we have, wow, seriously, do I have to do this for every named module? So what the heck do I do here? So I have to store self mod signatures. So for signature, oh, this is the dictionary now. So for name, signature in items. So then the modified signature with this name becomes the modified signature. Now the question is, okay, so how do I get the name of a module at runtime? So I just retrieve the modified signature based on the runtime module name. This seems bad. How do they do it here? Oh, I see. This is why they do it like this. Because at runtime, you know the original signature. So can we reuse this? So we have the signature. Oh, we have to do reverse matching, right? So we need a signature to name. Yeah, we need a signature to name module, which is exactly the dual of this. Is there a way to invert Python? How to invert Python dictionary? Yeah, they are one-to-one. Okay, I just write it in reverse. This is fine, but do I really need two? Yeah, I need two because I need to. Okay, so self base names is the reverse dictionary from. Oh boy, I hope this type is hashable. Sure, it should be hashable, right? Because, yeah, it's used as keys. So apparently, predictor, I guess our Python class is hashable? Like, is that, we're learning something new here. Our Python class is hashable? Yes, class instances. Oh, so they vary from the base object. Okay, so unless somebody modifies that, which is not the case. Oh, good. Okay. So we have the reverse dictionary, base names. Okay, so then we just have to retrieve the modified signature. So it's mod signature will be self mod. What do we call this? Signatures. At self base name of this at the signature, okay, and then we pass in, so then this becomes the mod signature. Good. Why don't I have visibility here? I need to unpack these. So mod signatures is self.mod signatures. Yeah. Base names is self.base names, because it doesn't work like that, right? Yeah, okay, now I have them. This should be base names, okay? And finally, we have to, this is a class, right? That's why it's green, which is exactly what it has to be. Because it's a type, yeah. Do I see advice? So we can do this. If advice is none, okay, so we start advice, which is either a dict or a none, okay. So this is the latest advice. If it's none, we just return the adapter. It becomes a dummy call. With the old signature. And then we can get the feedback, which is inputs. So we do for key in advice. Now, what did we call this field? We called it outcome. So this will be key underscore outcome is value. Okay, this is good, but there is one more problem. We need to build the trajectory too. Pass in trajectory and execution feedback. Okay, so inputs the outcome, and then we also want to do inputs f key. It has to be trajectory, or I guess we called it attempts, is same thing here. So it's either a dict or a none. I guess it's the same. We can synchronize this, right? Okay. And then We should data class this to be clean, data class this to be a bit more generic, because we may want extensibility in the future, but for now it's fine. Okay, we're almost done. So that's it. Then we take the mod signature, we populate all the attempts for the mod signature, because these have to be synchronized, right? So now we have attempts and outcome. We just need to store the attempts. I guess store attempts, right? Store attempt. So we do like this. We push it and then we pop if we exceed the limit. Yeah. Okay, this is easy. So if I greater than greater or equal to self dot, what was it, trajectory, if trajectory length greater than 0 and okay, I guess we can do a special case for 0 to do special case for 0. Yeah, because if we feed, I wonder if we feed to this, well, yeah, we could trick it here to not pass anything in the input, but then the model won't see anything. It's just, nah, we don't want that, right? So maybe not. Okay, so yeah, we don't want this. So and actually, let's keep it 0 then as the special value. 0 means infinity, right? So if we have a trajectory length and we exceeded it, and truncate trajectory. So we always push, so we always do this adapter is in the loop. I think it is in the loop. Eek. Yeah, it is in the loop, because I need to have visibility into the latest advice and attempts before code execution and before advice gathering. So the very first time the advice is none, then it becomes a dictionary. Same for the attempts, they become a dictionary too. And I can do attempts for this output dot append. It's a dictionary of what? For string. Oh yeah. No. So code is also string, right? Actually, because when I pass code, how do we pass code as input? Actually, it's just a string, right? As input type in code analysis. DSPy code Python. I mean, sure, Python get source, but what is Python get source? It's easier if I see it here. I guess we can use import inspect. Inspect.get source. Yeah, it's a string, right? So it always outputs a string. Yeah, we just want we already have the code, the output.code, right? So we just need to do append output.code. That's it. So it is a list of strings, the attempts. The advice is also string to string, because it's only the last advice. and always gets overwritten, and this always gets appended. And then finally, if we exceed the trajectory, attempts for the output dot pop or delete. Python pop first element from list. It's pop 0. That's it. So if we exceed the trajectory, then we do a rolling window, sliding window. I'm very curious to see how a list of code works in DSPy, but we'll find out together. Pretty interesting. Here it is. The type is this type underscore. Okay, pretty good. UVX rough format. Not too many changes. So pretty clean. In 140 lines, we have a pretty generic code execution. What do we do with quarks here? Oh, obviously we need to populate the actual, where's the prediction? Oh, here it is, none. So, oh yeah, we need to predict with this guy. So we say with DSPy, how do they do it here? I think they have an example here. Here it is. Yeah, this is the original module. I see, and this adapter propagates. Yeah, so what we did here should work for nested pretty good. So with DSPy context adapter is a feedback wrapper adapter. Outputs. Why do they get the mod as? This is so confusing. So LM. Also, they changed. I thought the refine was supposed to change the temperature. I guess not. Yeah, this is better. Why a deep copy of the module? And why a copy of the LM? Come on. So why would you want to know the rollout ID? Start, rollout IDs. What? Nah, you don't need this, right? I guess just for logging. So it's technically a different whose requests. Okay. So any provide keyword corresponding. Okay, so it's to prevent caching. Interesting trick, but you can just temporarily disable caching, right? With cache false or something. And I don't get. Oh, I see. So they deep copy to set the language. Okay, for this is good for now. Fine. It's okay, but it's kind of overkill. So we'll just call it self. Okay, so outputs, not pred. And finally, what is the base module? It's base module. Right, except it's with a modified signature and with the inputs passed in. Now we could build the module explicitly here, but the adapter solution is pretty clean, to be honest. Yeah, this and also this is an example of using two adapters on top of each other. Because my file adapter comes in now and I call its call. which removes that all that project metadata. Yeah. Okay. UVX rough format, pretty good, pretty good. No changes in files, just oh, there is a change in adapter. Stream. What do we change here? Oh, I see. We did a small optimization. Brief. Briefer use generation. Pom pom pom. SRC. Hello, hello. We have a first-time chatter. Or so we were going to add this to the Git. Okay, and now we can finally add the big boy we worked on today, which is feedback. Why is there one warning here? What's happening? Oh, something here. Oh, whoops. Oh, yeah. What does the big module return after everything is done? Well, here we can just return, it's just outputs, right? Yeah. If we reach this, we failed. The LLM failed to generate code that executes for all outputs. We'll have to deal with this somehow, but not quite sure how. Okay, so now we can add this and we can commit first version of feedback. Okay, so pretty good. This should be public now in the repo, which if you're watching is on my GitHub here. I can paste this in the chat. If you're curious to see what we've been working on, basically we've been using this DSPy library to write AI modules, and we're writing this problem-solving module, which is supposed to be like a competitive coding problem-solving, like lead code style. And the nice thing about this DSPy library is, if you're not familiar with it, check it out, but it allows you to compactly write AI modules, or to do inference with LLMs just by describing inputs and outputs. So in this case, the module has 2 inputs and 4 outputs. It has a text description of the problem we want to solve, and also a list of examples of inputs and outputs for that problem. Like, for example, let's say we want AI to solve this problem, this programming problem. Given an integer array nums, sorted in on decreasing order, consider the number of unique elements, find that number. Which is really easy. It's just a counting uniques problem. This is like an easy lead code problem. And then you give some example cases, right? This input should produce a 5 because there are 5 unique numbers in it. This input should produce a 1 because it's 4 repeated many times, so it's only 1 unique number, blah, blah, blah. But the thing is, we want AI to generate more than the solution code. We want it to also generate profiling code that profiles the runtime and memory, and test code that tests if the outputs match the expected outputs for the input cases. And then this is sort of the we're sort of working on extending DSPy to generate a coherent Python library that solves that problem. Because you not only want the solution code, but again, you want this memory measurement, but then you realize that, oh wait, I need to import the solution. So that becomes a Python import problem. Same in runtime. You want to measure the runtime, you actually want to run this function, you have to import it. Same for the test. If you want the test to exercise everything, and then it becomes a problem of how do we write these prompts to the LLM? Because we don't want to start writing all these prompts. So then we also extended last time what DSPy calls adapters. We now have our own custom generate use statement adapter, which sort of prompts the model. It takes as input a file structure on disk and generates instructions for the module on how should the imports or the import statements look like in Python. And today we also worked on a feedback module because we also want to execute this code and give some feedback to the LLM in case there are Python errors. And let me see. Yeah, in this case, for example, if I try to run what the LLM output, I think this one will work, but this one works, but it's by chance. The feedback module is not ready, but sometimes the problem is sometimes the code just doesn't work, right? If I try to regenerate this, so let's try to regenerate the solution with AI. Sometimes it generates invalid imports, or it hallucinates the name of a function. Let's see, does this look right? This also looks right. Oh, here, no, there's a mistake here. Okay, so here's an example of LLM hallucination that we're trying to fix with this feedback. So now it generated this whole 4 files that I wrote to disk, but it's still DSPy asking for 4 outputs. The thing is, if I look at the test, it tries to import from output.measurements.runtime a function called measure time. But if I go to this file, which is also LLM generated, output measurements runtime, the function is actually called benchmark. It's not called measure underscore time. I can see this in my code editor. Same for the memory, right? If I look, the LLM tried to import from output measurements memory import measure memory, but if I look in the memory, the path to this is correct because we told the LLM how to generate this, but then if I look here, the function is called measure, which is also wrong. So then if I try to execute the test, I get an error, obviously, cannot import measure time from output measurements runtime. Then what I was trying to do today is to feed this error back to the model. So then you want to run this Python code. It's basically like automating what I just did because I just typed by hand uv run -m output test. But this is automatable because I know where all the paths are. I know what the dependencies are. So this seems automatable. And then you try to run this in Python, and if you get any error, you capture that. And then you also use DSPy to feed that back to the model. Yeah, so this is how, let's say, a more refined use of AI would look like. Okay, so let's see. So we wanted to look at, so now we know we need to run, we also want to run all the files because there are 4 files here and they should all be standalone runnable. So for each of the code outputs, where was I? So we try to execute the code. We know the path to the code. We get a message. We store that message. And we also store the history of attempts. And then if everything runs, we can just return the outputs. And then we repeat this for a number of steps. And maybe we're lucky and the LLM kind of works. Okay, this looks pretty clean. Now we need to use this. So then all we have to do in DSPy, once we wrote this module that can take feedback, is we just have to use it in our main. So then we can say something like from stream.feedback import module with code feedback. And instead of using DSPy predict to do a single shot prediction, we can just wrap the module. DSPy is also like, I like to call it something like PyTorch for AI calls. Like it allows you to successively pass the inputs of an AI call to another AI call and stuff like that. Okay, so now we can wrap this. So we take our raw prediction and we wrap it in this module, which tries to run it by default 3 times. Oh yeah, and this also needs to be aware of the project structure. So the base module for this will be our predict module. Yeah, which can also be called, I guess we want to flag here. So if args feedback, then we wrap it. Okay, and we said this guy has to be aware of the project structure too, which is a class we wrote to handle the file system, because we need to know where the files are placed on disk to generate the run commands. Okay, and that's it. Only 5 lines in main, that should be enough. Okay, we need the feedback argument. Feedback. If there's any questions, feel free to type in chat or it can be anything. So this is a Boolean. Use execution feedback. Yes, so right now the success criteria, that's a good question actually. So right now the success criterion is a bit weaker than that, is we just want the Python code to run. Because if you look at, I just do subprocess.run, and if the return code is 0, which means that the Python code successfully ran, then it's considered a success. So that's interesting because the AI can sort of trick us here. For example, it can generate an empty file, which will also run in Python, and it'll bypass this. So that would be what they call that reward hacking, right, in AI these days. So we're not quite there yet to actually, because the LM could just generate a test that's completely empty. And this will run. If I try to run this test, right, output.test, it runs. And it returns the code 0. So to actually formally verify that the test passes is a bit more complicated, because we would have to intercept the prints, for example, and parse them. I don't think we're there yet, but that's definitely something for a future stream. But right now I'm just trying to mitigate more basic hallucinations where the imports are incorrect and the code just doesn't run. Okay, so we added the feedback. Let me delete this old output. So then I can run again. Okay, so now I'm gonna run with feedback. I think there's gonna be some errors because okay, yeah, I didn't get the syntax right in some cases. Let's see what is happening here. Okay, there's gonna be a bit of debugging here. Primitives module, self-based signature. Oh, of course, there is no base. It's base signatures, I think. Yeah. Did you mean? Yeah. Another interesting thing actually that happened here. The reason why I want to include the error. So the way the logic works is if the execution fails, we also include the error as feedback to the model. And you can actually see it's helpful here, for example, because this tells me that module with code feedback has no attribute-based signatures. Did you mean base signatures? And yes, I did mean that because the Python interpreter is smart enough to, I guess it does some parsing for you. But then if the LLM would see something like this would be quite helpful. So then I have to go, where did I call self? Yeah, here. So I did actually mean base signatures here. And this is exactly the feedback I want for the LLM because it's kind of helpful to me as a human. It sort of makes sense. Okay, string object has no attribute annotation. We're getting there. We are getting there for sure. Let's see, what is 44? So what do I have here? DSPy has output fields. And what's the problem here? Field is, it's just a string. Ooh. So what is mod signature? Oh, obviously, wait, this doesn't work like this because I think it's dot items, right? Signatures is dictionary. Mod signature dot output fields. Yeah, it's okay. It's a key value thing. So name and field. Okay, so it's dot items. And actually now I have the name here because I needed the name. Perfect. Because I also want to pass to the model previous attempts for that code. So this is actually how a DSPy signature looks like. You pass the inputs through what they call fields. Actually, let me paste this. Well, if you were curious, you probably found it, but DSPy is not made by me, but this is what I'm using. So they basically want you to just write a signature with input fields and output fields. And now what this module does is it takes the original signature and adds 2 extra fields for each output as new inputs, attempts and outcome, which are supposed to represent the previous attempts for that code file, and the outcome of attempting to execute the latest attempt for that code file. And then what DSPy does is it prompts the model behind the hood for you. It sort of uses these prompt templates, which you don't have to write by hand. Like it splits it into sections. Because even though it seems like we pass very basic inputs to DSPy, like a string that represents the problem and a list of cases, if you look at how it actually passes it to the LLM, it also has instructions that are templated. Given the problem, it has these headers, and then it also instructs the model respond with the corresponding output fields, blah, blah, blah. And then it also handles code extraction for you, which is really helpful. Like you don't have to parse this stuff. It will automatically extract Python code, or you can specify the language you want to. If you want, you can generate a mixture of Python and C code or whatever. And it automatically extracts it and just gives you the code. So that's why it's easy for me to write it to files on disk. Okay, so let's see what happened here. So name and field. Okay, so now if I look at, for example, let's see, solution, what does this have? Oh yeah, okay, this is annotation, and it has a basis, yep, which is DSPy code. All right, this should be DSPy code. No, it's not. Ouch, there's a mistake here, or what's happening? What class is this? DSPy adapters type code, and this is not. I'm very close. Oh yeah, this is also name here. Outcome. Where else do we have output fields? That's it. How can I detect if something in a signature is code? In this case, I know it's all code, but it doesn't have to be, because DSPy allows you to also output, like I could easily write, I could ask the model to also output an explanation. Okay, so here's how you would extend this. So actually, maybe we should keep this. This is good to stress test it, because you can also just ask the model to output an explanation, which is a string. And all you have to do is write the small natural language description, an explanation of the implementation of solution. Now, if I rerun this again, without the feedback, because I broke something there, but it's fine. This will, okay, so there is a bug. Okay, this is good to, okay, good. So I know what's happening. So yeah, okay, so early exit for non-code fields. So I am actually trying to write that to disk, and of course it's crashing because it's just a string without any dependencies specified in the file structure. So then we can say, okay, perfect. This is exactly what I need to fix here. So if get attribute, it's exactly this. But why the heck does this not work then? This is exactly the same problem, which is kind of perfect. You would think so. Actually, let's move this explanation to be the first output. So that way I see it faster. Okay, so then I can run again, and I'm gonna breakpoint there. Oh, because strings don't even have an annotation. Oh boy. Okay. I see what's happening here. Okay, good. This is fixable. Because the string field doesn't even, it just has a type, which is the basic string. So first oh, I see, it's somewhere else. I'm making the same mistake twice. Oh, sorry, I'm in the feedback thing, not the adapter here. I wanted to place myself here. Okay, so then let's see what the field has. Oh, no, I'm making the same... I'm making the same mistake here. It's name field in items, and the field has the annotation. Now the name, I have to use it everywhere now. Okay, this is more consistent anyways. Name, where else? Name. Okay, so what the heck do I have in the field then? Oh, so I must have an annotation then, right? Or maybe not actually. So field, oh, it does have an annotation and it's just string then. And this one doesn't have bases probably in Python. Oh, it's just an object. Okay, so this will skip. My problem is, if I go to the next field, which is a code, and it has annotation code Python, and if I look at the basis of this, oh, I know what's happening here. It has to be a tuple. Ah, okay. This is equal to the tuple formed by DSPy code. Yeah, okay, good. Okay, so this is solved. So, and we also fixed the early exit for non-code fields. So the fix is to just check for a tuple, not, okay, good. So now let's go back to the, before I go back to feedback, let me go back to actually seeing this explanation to see how easy it is in DSPy to just ask the model for more stuff without having to prompt by hand or maintain long prompts. I'm using a free NVIDIA model, by the way, from OpenRouter. It's a pretty weak model. It's a 30 billion, active 3 billion, but you can use it for free. Okay, we're almost done, except I made the same mistake again. I still tried to write it to file here. So for key and output fields, if it's exactly the same thing, write the Python code to files, but I forgot to check if it's actually code. So if same problem again, name field, to be more consistent, look into items. So now if the annotation is not code, continue, otherwise name prediction name.code. Okay, now we should, let me delete this output. Okay, so now the whole output is still on disk. Again, the LLM messed up here because it hallucinated measure runtime, which is, there's not even a function defined here. So this will fail, so I can't run test. Yeah, cannot import name measure runtime, but this is something for the feedback to fix. What's interesting though is that the explanation field was not written to disk, obviously, because it's just a string, it's not code, but it was output by the model, and you can do things with it if you want to pass it to another model. And you can find it by looking at the raw history. Solution, oh, here it is, explanation. The LLM figured this is basically a justification for the code written by the model. The array nums is already sorted in non-decreasing order, so all duplicate values, this is correct. We can count the unique elements by iterating once through the list, blah, blah, blah. This is true for this problem because it's a really basic problem. We still need to work on more data because right now we're just using this dummy problem. But then you can take this, you just have it in Python as, where's the prediction? Here it is. So if you look into pred.explanation, this is already extracted for you, this exact explanation. And then you can write, I don't know, you can do another thing, like you can write another DSPy module, like an analyzer, right? Which uses DSPy predict with some other signature. And you can just, you know, you can analysis equals analyzer with explanation, right? Like you can ask another model about the explanation or do things with it. You would have to write the signature, of course, and now for this signature, explanation would be an input, right? It was an output here, but you can just take this, copy, well, you don't even have to copy paste it. DSPy has built-in ways to reuse these, but yeah, maybe we'll, it's pretty nice overall. So, okay, good. So we fixed a bunch of stuff. Let me see how we're doing. Rough format, not too bad. Let's upload what we worked on. So src stream main adapter and feedback. Fix non-code output processing. Okay, this should be live on GitHub. And now let's try to run again with the feedback, which is we just run with feedback. And let's see what, there's probably more errors, but we're kind of getting there because now we also, okay, there is, the field has no attribute language. Oh, interesting. Why? I thought the DSPy code objects, they have a language. Ooh, where is this? Feedback 51. Field language. Interesting. Let's see what it does. Oh no, wait, but no, I left the explanation in, but this should be fine because it shouldn't get past this, right? Yeah. No, this is fine. That's not what's happening. So let's see, if I stop here, what is the field? Okay, it's a code. Oh, sorry, the language is in, it's in somewhere else. It's not field.language. It's field JSON schema extra. Oh, it's not here either. Oh no, it's in the annotation dot language. Yes, okay. So it's not field dot language, it's field, whoops. Annotation dot language, and actually you need a lowercase here. Okay, do we use dot language anywhere else? Project language is fine. That should be Python because I said that. Okay, we're pretty close now. Whoops. Okay. Again. Okay, I think stuff is actually running now with feedback. Very close now. I caused some more trouble with that explanation field because it's trying to manipulate it in a certain way. Let's see what's happening here. So very, very close now. So 122 artifact path. Same problem. I forgot to filter. So for each code output, obviously. So for code outputs only, it's exactly the same logic. Which makes me think we should not copy paste this much code. Something is fishy here. So I look at the output. Okay, I made the same mistake. So name field outputs dot items. Okay, so we want the name, the advice for the name, the attempts for the name. Okay, but the field annotation and the field code. Let me see, what do we have the outputs here? What are they? Okay, the attempts here is wrong because I don't need to overwrite this. That's another bug. So the advice is always the latest one, but I want to keep all failed attempts. So we can just do like this. If attempt is none, we can just reset this to a dict, okay? But what I wanted to see originally was what are the outputs here? So the outputs come from the, okay, so now we should actually see, okay, interesting. So we should see everything now. Oh no, it's just explanation. The arrays are sorted, solution. So if I look at outputs dot items, explanation, field. The problem is this, okay, I know it's gonna, this is not good because, oh yeah, this, we're not in signature world anymore. This will be, the field itself will be a string, so it's not gonna have, well, is that true actually? So outputs of solution, what is this? And does it have an annotation? Nuh-uh, it doesn't have, so no, this is not gonna work. So we need to, what is the type of this? I need to detect the type of outputs solution. So it's a code Python, but this is an inherited class. I want it to work for any kind of code. Is it like .base? Yes, okay. So this is DSPy code, right? Yeah, okay. And what is the type of the non-code output? Like we called it explanation. Obviously a string. And what is the base of a string? Object, okay. So then the check is different at runtime, not at signature. I guess pre-runtime. So type outputs, oh no, sorry, field, the type of the field. The base of that type should be DSPy code. Otherwise we continue. So if it's not, we move forward. We don't do anything with that output. There's no feedback to give. Okay, looking much closer now. Again, let me clear the output folder. Okay, very close. What the heck did I do here? If attempts is none. And this is not, oh, it's misspelled. Okay, obviously, attempt PTS. Okay, even closer now. Almost. Why is there no key error for solution? What? Is this not a dictionary or what's happening here? Attempts? Oh, I can't append to something. Oh my god. Oh, that's not how Python dictionaries work, is it? If I just do x equals dict, I can't just say x.a append 1. Yeah, of course I have to create it first. Okay. Okay, so we can do it like this. If Can I do none plus in Python? Does this work? None plus 1? Nuh-uh, it doesn't work. I need an empty list there. What the heck was it? So, oh, it's default dict, right? Python default dict. Yeah. Okay, so I need a default dict. I need this to be a default dict with list. And I think it's from collections or something. From collections import. Yeah, okay, so now every key that doesn't exist is an empty list. Then I can append to new keys. Yeah. Okay, good. By the way, I have, let's see, so I also have a YouTube channel where I uploaded, this is the 4th time I'm streaming sort of this series, but I don't even know if I have the YouTube channel in my Twitch, but oh no, anyways, I can post it here. I just dumped the VODs there from the past streams. If you want to check out all the progress. In the first stream, I actually kind of tried to explain. Well, everything we wrote here is from scratch, so I wrote all the signature. Okay, yeah. Oh yeah, because it's on the GitHub. Yeah, so the first stream is kind of wonky. It was the first time ever, but I've been getting better. But pretty much we can always just, you know, if you have a task you want to solve, we can just write the DSPy module like right now from scratch. Like any type of question answering module or any type of judge. LLM judges are also pretty hot these days. We can always mess around with that. Okay, so I think this is the ARC challenge. Yeah, the ARC challenge is one thing I will say is that DSPy doesn't, I don't think they have image support that well. And I know the ARC challenge is, but maybe not really. I think it does depend on how you encode the info. So as long as you can figure out the signature, that's a good idea actually. Oh, it's in JSON. Oh, it gives you the, okay. Oh, okay, so it's not actually image. Oh my bad, yeah. Yeah, and it's all grid world, right? Like it's guaranteed to be grid world. Yeah, that's DSPy has more advanced features too. It has this automatic prompt optimization that I've messed around with in the past. I think that's not a bad idea because there's this. So another big feature of DSPy, I don't know if you know this one if you're in the field, but there's like this whole hype about. Yeah, it always has to be like this. I think, yeah, it has to be feedback based. But there's also this GEPA thing, which is supposed to automatically optimize prompts. And this also is in DSPy pretty easily. And the way it works is pretty simple once you get DSPy. It just uses, it's kind of similar to what we're writing here because it uses another LLM to observe the interaction and to suggest a better signature. Like it will basically replace all these fields here with more specific instructions. So I think that may work for something a bit more contained like ARC. I don't think I've seen something like that. That's not a bad idea. Let me write that down, like messing around with ARC. I may do a series on that. Yeah, exactly. So exactly, it is RL. Yep, it's RL, but it's only in the prompt though. It doesn't change the model weights. So what it means to have a better signature, it means to write more instructions here. Because I could have also written here by hand, like do not use brute force implementations, right? I could have also written in problems with graphs, I don't know, try some algorithm first. So then what this JEPA thing does is it takes a data set, which in our case it would be like a set of problems, but it leaves it to the programmer. You have to write the metric function, right? So define metric, which takes as input the DSPy predictions. In this case, let's say it would be pred, right? But then for us, for this case, actually, it's pretty easy because all you would want to do is you would extract the solution. You would just run the profiling code, right? Or you would just extract let's say you would extract the runtime code, and you would execute it and measure runtime and return the runtime as a metric. And then it will minimize that, right? So you have to write your own metric, basically. But actually, with what we're doing now, we're pretty close to that because we have the execution part. Of course, it's still prone to hallucination, but the idea is that you have another model observe all of this and propose better instructions here. Because, for example, the big model, you're supposed to use powerful models for the reflector, they call it. So that model could also write here, do not write empty solutions, right? Which you can write as a human, but it's supposed to automate all of this stuff. So pretty interesting. Yeah, I'm basically on the path to getting that enabled. It's like 10 lines of code or something, and you just run it on any signature, and you need a data set for it though. Yeah, exactly. It's a judge and and the feedback giver. The thing that we're missing is data though. I need a lead code data set, which I'm pretty sure there's a lot around. So that shouldn't be too hard. But then arc is also nice. Do they count? Do you know if do they count the number of? They must count the number of steps too, or something, right? In arc probably, because then if you would have a cost function there, that could be something systematic. All right, so I think this was pretty close. Let's see with feedback. Very close, very close. Feedback 106. What's happening here? Yeah, you can. Yeah, this is why I said DSPy is like PyTorch, right? Because if you think about PyTorch, like even in neural networks, you just call a layer after layer. So you can just write a for loop that judges the judge, the judge, the judge, and it's gonna be like 4 lines of code. As long as you find a way to systematically write signatures, which I think is possible. Like the judge signature, even when you nest them, it's all about signatures, right? As long as you find a way to, because the first judge signature will be different than the task one. Right? Like if you were to write the judge here, like solution judge, right? So let's say we write, so you are an expert. I'm not gonna write too much by hand because the whole point of DSPy is to rather chain modules than write by hand. So we can do like, you are an expert code evaluator focused on optimal implementations. That's it, okay? So then I'll say candidate, which will be a piece of code in the language. It'll be an input field for this judge. With the description, you have to write the small natural language description. The code, whose complexity will be evaluated, and then you can ask for suggestions, which is a string now, and it's the output field. Suggestions to improve the performance of the code. without sacrificing precision or correctness, let's put it. Okay, this is kind of okay. Now, of course, we can easily call this now because we can, but the thing is, what do we do with the suggestions? Then you would have to, so you can chain it with this guy. So you can go back to this guy and say suggestions, where this guy is an input field with the description is suggestions from an expert programmer on how to improve the code. But there is a, what did I do here? Oh, I forgot to annotate it. It's a string. Yeah, exactly. And we're never gonna stop basically, right? But the problem is there's a causality now because I need a previous solution now. Because this guy doesn't know what to improve, right? So I also need, if I do this, I need a previous solution, which is the previous code. And in the first step, it'll start from nothing, right? It's also an input field with the description is the current solution to the problem. Okay, so now you can call these guys in a for loop, right? You call the, and we can actually do it. Let's just do it here, I guess, on the spot, right? So you can do coder will be, I'm going to use the predict. Well, let's use the chain of thought module with this signature. And then the judge will be also chain of thought with the judge. Okay. And then you can say steps is 3. And for in steps, first you get the code. So you do coder. I need these inputs here. Kind of, because let's see. So I need local inputs is inputs, but then I also need to add. So for the first step, so if I is 0, because there is no suggestion or previous code, right? So I need to add something there, right? So I can say, what they call previous solution. There is no code in the first step. Empty and not solutions, suggestions. Okay, I get the thing. So coder local inputs. Predict solution, then I judge it, and then I pass the feedback around. So the feedback just becomes, so the judge becomes, judgment will be judge. We have to form the judge inputs, which are, there's just one. Candidate, it's called candidate, and it is the prediction solution code, because you have to reach into the code, and then you judge the inputs. Okay, and then you pass the feedback, which just means oh no, actually I can capture this here. All right, so it just means overriding these two guys. Now my previous solution becomes my current solution. And I take the judge suggestions, judgment.suggestions. Okay, that's it. I think I chained it right. And then I can write the history. Let me write this. And breakpoint. Okay, so now let's run this 3 times. Let's see what happens. Files. Without the feedback. Because we also have this explanation field, so we should actually see an explanation for what the student, what's happening here. Oh yeah, because the judge is trying to judge. Hang on. This is some. Why is my project field leaking here? Well, I can just run it without files then. This should be fine. Why is my project field? Okay, it's definitely working now. It's gonna take a while because it's the free model. It is a bit slow. Interesting. Okay, there we go. So let's see the history. Because it should have written all the rounds. So this will log everything that goes to the AI. So first we start with the, I also use DSPy. Let's see what happened here. Oh no, I should have captured more history, my bad. Hang on, I have to run it again because actually history of 5 is not enough because there are 6 steps. Let's try to capture everything. And I guess let's just use predict for the coder. Let's use a more basic module. It's definitely working. It's just so okay. There we go. So now if we look at the history, so it starts all the way from the. So now we have 5 inputs for the coder. We have the file structure, which we really shouldn't have. This is my change, which apparently breaks stuff, but it's disabled. We have the problem, the test cases, the previous solution, the suggestions, and we have 5 outputs too: the explanation, solution, and this profiling code. Then this is the problem. Okay, so then he gives a solution. I don't know, he does something, right? And a bunch of code, and then the judge kicks in. Okay, the judge kicks in with a single input, candidate. Now, because I use chain of thought, it actually has a hidden output. It also has a reasoning output and suggestions, but the reasoning is, again, DSPy handles all of that for us. I didn't have to actually ask the model to reason carefully. So let's see what the judge thought. So he saw this input, he did some internal reasoning. The function iterates over the list once, comparing time complexity. Okay, the code correctly handles the empty list. Well, other cases, no logical errors are present. Therefore, the overall time complexity is all event. Okay, so he sees it's optimal. It's also the space is optimal. So what the heck did it say? Suggestions. Oh, okay. So it did code cleanliness suggestions. Replace the manual index loop with a more Pythonic iteration to reduce overhead using a local variable, blah, blah. Leverage built-in. Okay, so it even gave an implementation that reaches into a Python tool. I didn't even know this. It's like a one-liner. Group by consumes the iterator once and constants. Consider a set based. It gave another solution, blah, blah. Now this guy sees it again. He sees the previous solution and all these suggestions in the prompt. What does he decide to do? he picks the most concise and fastest way is to exploit the fact that equal values, he chooses Python's whatever this thing is, itertools.group by, because it leverages the C level, blah, 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 blah. Okay, so he outputs a one-liner now, which is arguably faster. This is why it's nice. This is what I want to do. Like, we actually have the runtime code now. So ideally, we would pipe all this stuff together to actually measure runtime. Okay, but the judge sees it again because we do 3 rounds. What the heck does the judge say now? Okay, he gives a much shorter suggestion now, right? Because there's really nothing to do, right? Because he sees that it's whatever. Then he says add a precondition check. Okay, so he wants check, otherwise either sort the list, consider using length set nums for blah, blah, blah. And finally, what does this guy do again? Previous solution, suggestions. Okay, well, he kind of breaks everything. Like, the problem is, but the thing is, now this guy, he had this one-liner, but he saw these suggestions and he said, oh shit, I gotta do a bunch of stuff now. So he does an early exit. He actually implements the suggestion. Yeah, he verifies that the list is sorted. Then he goes back to previous implementation, so he kind of broke it. Yeah, so now the thing is, if we had the profiling and we actually measured it, you could use that as a more grounded metric. So yeah, it's a bunch of stuff. And then, like you said, we can also judge the judge, okay? So we can write another judge, like judge, okay? And this one tells the judge if he should stop or not. Like, look at what you suggested before, look at what your student did. Now, if you don't think there's anything you can do, tell the student to stop. Or, I'll put an explanation about what you did and why it's bad or something like that. Yeah, you can keep chaining these, and it's pretty easy. Yeah, like we did this in like 10 minutes now, right? As long as you are familiar with the basic signatures. Okay, so yeah, this was a nice exercise. I also found this bug with the, so actually now that I found that bug, might as well run it because something fishy is happening. If I run with files, I think this is a good bug actually. This project should not leak. Yeah, something is leaking here. So my adapter line 59. Oh, I know why. Of course, because this guy also uses a project. Okay. Trivial. This is trivial to fix. So how do we not use... Okay, so I just have to override the judge here. So with DSPy settings, adapter is DSPy chat adapter. Because the judge is not aware of the file structure, because the thing I wrote is a bit more custom. Well, it was heading towards actually running the code. So then if I just override this, let's see, is this how you override this? DSPy, what is it, with? Oh, DSPy context, sorry. Adapter, yep, like this. Okay, this is actually an important fix. It's a good reminder that I know what's happening here. So actually I should not run this. I should actually run this the other way around. Okay, good. Let me copy this. I'll just upload this for fun on the GitHub. So let's do a judge.py. So we have it. I may come back to this, but it's, yeah, but that JEPA thing is supposed to be really nice because it can also improve both the judge and the student at once, and it can go all the way down, basically. I'm just gonna take this whole thing actually to have them here. And we don't need the project here for this one. And we can hard code the language to Python too, because we no longer depend on files. Okay, let me see, restore this, so I can restore all these changes, yeah. And then it just becomes something like this. Okay, local inputs. Oh, I need the problem too. I guess I might as well copy it. Okay, we don't need this project here. Okay, this should be runnable. We don't even need this thing. So then you just need the DSPy language model and the configuration. And as long as you have a free open router account, you can generate the key. And this is, I'm not paying anything, this is a free model. I think it's limited per day or something, but it's fine for messing around. Okay, and then all you want to do is import, do the history thingy. All right, so this we can restore. Oh, here it is, do the history thingy. So this will dump to file the whole interaction. And that's it. This should be standalone runnable now. Let's check that. So I can run uv-run.m stream.judge uv-run-m. Yep, there it is. And I didn't mess with too much of this. Okay. Yeah, this is running and it'll write history. So I can, yeah, the other nice thing is I use UV. So all you have to do is just install. And if you just UV run this, that is literally it. So then we can UVXRough format. Okay, so git add src stream judge, add toy judge example. Okay, that should be live now. So you can actually run this. The only thing is you need to get your key, but if you just make a free open router account and you generate your key and you do the environment thing, that is it. You can play around with this and it's basically the crash course into DSPy. What else did we change here? Oh yeah, we were in the feedback thing, right? Stream feedback. Oh yeah, we fixed the default dict. I think we're very, very close, right? Yes. Is there any breakpoint? No. Git add src stream feedback commit-m fixes. Okay, let's try to run it one more time. Actually, I should invert the logic here. Now that we found that other bug, there is something nicer. So what we should do is I need to just run this guy with DSPy context adapter is file adapter. Then I want to run this, and I don't want to disturb the vanilla adapter because then I won't be able to write other modules that don't use code. So this looks cleaner too now. Good. Okay. So then we have this, and then I do UV run. What was it? Stream files and feedback. I think this is very close to getting the execution feedback. There's probably a few more typos. Oh, Oh yeah, there's no self. Okay, I remember this. So 106. Oh, what? Here self? Oh, what the heck is this? Is this self aliasing the self here? Is that not how it works? I thought they did it this way. Alright, fine. Forward self. Yeah, this should be fine. So what is self here? Yeah, this is feedback wrapper adapter. Okay. Next. Key error self. Oh, I see. Because base names and signature. Oh God. Wait, so what the heck is base names? Oh, this is a problem. So base names. What keys does it have? Okay, I know what the problem is. I'm building this base names wrong. Value key for key value. Self base names. This is a Python syntax issue. So base names dot keys. What? How many keys does this have? Because it should have as many keys as code outputs there are. 1. That's wrong. And base names dot values. Okay, obviously it's not. Okay, so this whole thing is busted. Okay, so then it's broken here too. Then. Okay, so let's see, self.baseNames.values. Yeah, this is broken. Okay, so then why? Value. So my base signature is also broken. Base signatures dot keys. Yes, it is broken. Okay. Because my name is broken. Oh, what the heck, dude? What is this? Name predictors dot keys. Name predictors 0. Oh, this is not good at all. So DSPy returns a self here. But why can't I use then? So what's the problem here? So I cannot use mod signatures. Base signatures items. So mod signatures. Oh my God, this is the, I'm so dumb because I'm overwriting this name variable. Okay, easy fix. This is field name. Okay, well that was easy. So field, I'm overwriting the name here. So this is field name, field name, field name. Okay, no more, right? Name is name. Okay, that's it. Everything should be fine. Everything should be fine. Okay, I think this is actually working now. If it takes long, that's good because it's reaching out to the API. Yep. Okay, so now it's actually trying to run the code. But it's not gonna work because I'm now realizing that we also need to write the code. Interesting. So this seems as if, yeah, okay, so it tried to run the code. I know what happened. So it probably, let's see, is there execution feedback? The problem is I need to write the code earlier to disk, which is actually, okay, so I need to write it here. Damn, which, yeah, okay, I missed this. So we need to modularize the write function because I only write the code at the end, but that's not enough. I'm pretty sure this works just by chance if I just, yeah, I mean, it is gonna work. Yeah, it actually does measure stuff, but I don't think there was any feedback because we didn't actually write it in the feedback function. Okay, so write the Python code to files. We're gonna have to initialize the modules early, which is fine. So this writes all the folders for us, but not the files. The files we can write the inputs. There's also a special case where I have to write an input to file, which is actually harder to catch in DSPy. Well, it's also not code, so I have a convention, but this is fine. Okay, so we statically write the input. Now, yeah, so this has to become dynamic now. Write the Python code to files. This cannot happen at the end. So let's just modularize this. So let's call it write code and write the code to file. So what does it need? It just needs output fields. It just needs output fields. Okay, and it can just directly reach into output fields. And it needs a project structure too, which is a project. And output fields is, I don't know what this is. Well, actually, let's see. Let's do it with pred, which is a DSPy prediction. Okay, so then you have to look into the pred, and where was that thing that we said? We have a runtime check thing now, not a signature check. I swear I just did this. It was the type thing. Oh, here it is. If the type... Okay, so if the type of this field is not called, continue, otherwise write it to where the project structure tells you to write it. Okay, so now this can move. And it can live in our adapter next to our file. And then we can just import it here. So from stream adapter, import write code, and then every time we predict, where is the prediction? Here. So we get the outputs. just write them directly. So write code. We need output and self.project. That's it. All right, self.project is the project structure. Yeah, it's a project object. Okay. Oh no, sorry, not this one. So this should work now. This is good because we cleaned up the main a bit. And we don't do anything with the prediction here, but this is fine because oh, there it is. So it started writing it. Okay, so it's writing it incrementally. And did we have an all pass? We must have had an all pass then. Dash run output test. Yeah, it runs. Okay. I think this is it. It just happened to work on the first try though without feedback. But eventually, oh whoops, eventually it should not work and it'll need one round of feedback. I think this is it. Yep, it's trying to run now. Okay, now it has feedback because it wrote something, but it's still running. Let's see if it gets it eventually. Okay, is it running? Nuh-uh, it didn't fix it in 3 steps. It's possible the model is just too weak, so... Oh, I see, it's trying to, it's hallucinating this get input function from cases, which doesn't exist. Cases is just a... Interesting, that's still my fault because I prompted to always import functions. But cases is a special case. So let's see what happened with the... Do we have any history here? Yeah, we do have attempts now. So why did this not work? But also, where are my special... are they not captured or something? Ugh, this is so annoying. Okay, so UVXRUF format. What did we change? Functioning end-to-end feedback. This should be it. Except something is fishy here because this test in the middle seems to have worked. It had the right import, but somehow it changed. Is my early stop not working then? Let's see. Okay, well, we have to debug this function by function. There's probably some logical thing here. Let's see what the advice is. So where the heck are we? Okay, here. Advice should be a dictionary of Python run errors for each of the functions. Yeah, I can't see. Okay, so let's see. Advice. Okay, so solution, code executed, memory code executed, test. Okay, so test has an error in this first step. Oh, wait a second. This is interesting. This is okay. So the code runs, but the test fails. What? Oh, I know why, because, okay. Okay, so yeah, everything runs, but the assert hits and it triggers a... so this also becomes repair now, which we kind of don't want to yet. Huh, interesting. So now it takes all this feedback in about the solution runtime memory. And is it smart enough to figure out that it works? Okay, what happened now? Advice? Nah. So now runtime has a gigantic problem. So if we print what happened when trying to run the called runtime, which measures time complexity, trace back file, blah, blah, blah. Okay, so this is just a hallucination. Cannot import name get case from output cases. Okay, this one is broken. What else is broken? Everything is broken. So it's trying again. Okay, everything worked now, the fourth try. And that's it. Yeah, okay, so it kind of works. It's a weak model, but it sort of fixes things. Okay, so the only thing left to figure out is why the heck don't I see this advice in the history capturing, but that's probably a DSPy bug-ish thing, maybe. Not sure what happens when you replace the adapter, like hot swap it here. Okay, I'm gonna stop here, but yeah, thanks for tuning in. This stuff seems to work when glued together. It's getting there, yeah. So next time we'll try to improve this and maybe try to get actually a metric function or something. Although my point was that my intention was that the test, yeah, it does report the runtime too. Although I don't know, this is not going to work. Oh yeah, another thing is we need more data. So maybe next time I'll try to find harder problems for the AI to solve. This one is really easy. Yeah, thanks for stopping. Yeah, it was great having you here, and I'll upload everything to YouTube, so even if you don't get a chance to tune in, you'll always find the VODs there. All right.